Hello, I am Professor Muhammad Naeem Ishaq, and after watching this video one will be able to answer the following questions. What is a frequency distribution? How to differentiate a discrete and a continuous frequency distribution? What are different rules about deciding the number of classes? How to find the class width or class interval? How to decide about the starting point of the frequency distribution? And how to determine the class limits for the frequency distribution of given data. Let us start the proceedings. The concept of frequency distribution and the construction of discrete frequency distribution have already been pretty well explained in one of my previous videos. The link of the video is being dropped in description. Here we will deal only with their definitions. A frequency distribution is a tabular arrangement of values of a discrete or continuous variable in groups or classes along with their corresponding frequencies. A frequency distribution can either be discrete or continuous. A discrete frequency distribution is either a simple arrangement of values of a discrete variable along with their corresponding frequencies, or is a grouping of values in different classes or groups along with their respective frequencies. The continuous frequency distribution is defined as a grouping of values of a continuous variable in groups or classes along with their corresponding frequencies is called a continuous frequency distribution. Now, in the steps involved in construction of a continuous frequency distribution, the first step is finding the spread or dispersion through the range. Range is the difference between the largest and smallest value of data. That is, range is equal to xm, the largest value, minus x naught, the smallest value, or range is equal to xm minus x naught. The next step is deciding about the number of classes into which the data are to be grouped. The number of classes should be between 5 to 20. There are many rules on deciding about the number of classes, but here we will discuss three commonly used rules. A good rule of thumb is k is equal to under root of number of observations, or k is equal to under root of n, where k, the number of classes, is always taken without a decimal point. According to the rule, if we have 5 to 9 values, the number of classes will be under root of 9 is equal to 3. For 10 to 16 values, it is under root of 16 is equal to 4. For 17 to 25 values, it is under root of 25 is equal to 5. For 26 to 36 values, it is under root of 36 is equal to 6, and so on. The second rule is similar to the previous one and is 2 to the power k rule, which can be explained with the help of a table. The number of classes k is given in one column and maximum number of values against each value of k is given in the second column. According to the table, k is equal to 3 classes are used for up to 8 values. K is equal to 4 classes are used for 9 to 16 values. K is equal to 5 classes are used for up to 32 values, and so on. The third commonly used rule is H.A. Sturge's rule, which gives following expression: k is equal to 1 plus 3.322 log of n, where as usual k is equal to number of classes and n is equal to number of values. And that's all about the number of classes. The next step is deciding about the class width or the size of class interval, for which we use the following formula. Class width is equal to range over number of classes, or I is equal to r over k, where r stands for range and k the number of classes. On deciding about the starting point of the frequency distribution, One can use the smallest value of given data set as lower class limit of the first class, but generally a multiple of 5 or 10 is used as starting point depending on the data provided. For instance, if the smallest value is 43, the starting point may be taken as 40. Now, in determining the class limits, we first determine lower class limits. The starting point is the first lower class limit. To get the second lower class limit, simply add the class width to the first lower class limit, and similarly again add the class width to get the third lower class limit, and get the rest in the same way. In configuration of upper class limit, in spite of adding, subtract 1, 0.1 or 0.01 from the second lower class limit and get the first upper class limit, and once first upper class limit is found, simply add the class width in it and get the second upper class limit, and so on. 0.1, 0.01 or 1, what to subtract surely depends upon the value of the provided data, whether there is 1, 2 or no decimal points. For instance, the required class limit may be 40 to 49, 40 to 49.9 or 40 to 49.99. After the class limits being configured, the last step is drawing telebars and assigning respective frequencies to all the classes of the frequency distribution. A summary slide is also given to sum up all the steps. That's all about the construction of a continuous frequency distribution. If you find my video informative, share it with your fellow students and subscribe my channel Statistics Made Easy One for latest uploads. Take good care of you. Thank you.